So hello friends, in this video we are going to solve this problem on HackerRank and it's Manasa Loves Maths. So let us read the problem statements. We are given with a number n and you have to check with whether any valid permutation of this number n is divisible by 8. So if there is some type of this valid permutation which is divisible by 8, then you have to print yes, otherwise you have to print no. So this is the problem, and let us see how can we approach this problem. So what will be the brute force method of approaching this problem? The brute force approach will be to you know to have every possible permutation of the number. So if I'm given number of length n, then I will be having n factorial total permutation of this number, and I will be checking all these permutation and seeing if any of those number is divisible by 8. So this will become a very costly algorithm. So this brute force approach will be a very costly approach. It will be costing me somewhere around, it will be of the order of n factorial. So this is not an acceptable solution. One more solution is that you suppose you are given a number of length n, and then you generate every permutation of length 3 from that number. So first of all, let us see what is the divisibility test for 8. So the divisibility test for 8 is that the last three digits of any number must be divisible by 8. For example, if I am given 3, 9, 1, 2, 8. So here you can see these last three digits. These are divisible by 8. So that means this whole number is divisible by 8. Okay. So this is you have to see the last three digits, and if these last three digits are divisible by 8, then the number is divisible by 8. But we cannot apply these brute force technique because it is very costly. It's of the order of n factorial operations. Another approach is that if you are given this number and we generate every permutation of length 3 from this number, so this will be of the order of n into n minus 1 into n minus 2 algorithm. Okay, so this is also one approach, and then I can see if this number of length 3 formed of length 3 is divisible by 8. If it is divisible by 8, then the then the whole number is divisible by 8. So this is also one of the method. But let us see if we have some better approach. Let us see if we have some approach in which we can have some better efficiency for this algorithm. So I am going to do one thing. So here you can see I have this. Suppose I am having this number 9, 1, 2, 3, and 8. Okay, I'm having this number, and in this number there is a valid permutation of this number. There is a valid permutation which is 39128. Okay, this is a valid permutation of the number, and the last three digits of this number is divisible by 8. So we have to print yes in this case. We have to print yes if we are given with this number n. If this is the number n, then we have to print yes. Why? Because the valid permutation of this number is divisible by 8, so we have to print yes in this case. Okay, so let us see what can be a better solution. So a better solution will be that I take a count of all the digits which are occurring within this number. So I will take a dictionary for that purpose, and I will see that the count of 9 in this, this is the number n, this is the number n. Suppose I change this number, I take this number to be 9, 1, 2, 9, 8. Okay, so I am given with this number. Suppose this is my number n, and I want to see whether any valid permutation of this number is divisible by 8. So I will take the count of every digit in this number. So the count of 9 is 2. The count of 2 is 1. The count of 1 is 1, and the count of 8 is also 1. Okay, so I will generate all the possible three digits number which are divisible by 8. This is easy for me. I can just generate them through a loop, and I will take all these numbers one by one, and now when I encounter 128, I will check 128 also. So the count of every digit that is occurring on this number. Suppose I take the count of this number into this dictionary, suppose p. So p1 is coming out to be 1, p2 is coming out to be 1, and p8 is coming out to be 1. Okay, in this way. So I will generate, I will run a loop for all the for all the keys of this dictionary P, and I will check if the count is less than or equal to the count of this dictionary D. If this is the case, then definitely I can have a permutation of this number n, which through which I can form 128. Okay, and if I can form 128 out of this number, then that means that this number is divisible by 8. So this is the approach which I'm going to apply. In the case of a single digit number, it is very simple. For single digits, it is just the number 8 and the number 0. Okay, and for two digits number, I just need to check the number and its reverse. But the problem will arise when we'll be given numbers which are greater than length 3. So now I'm going to code this solution, code this problem. So here comes the problem. The name of the problem is Manasa Loves Maths. Okay, so let us solve this problem, that is Manasa Loves Maths. And first of all, I'm going to apply a method. That the name of the method, I say, suppose calculate the frequency. So if I'm given with the number n, I have to calculate the frequency of every digit that is occurring in the number. Okay, so this is what I have to do. So this is quite easy. I will just take a dictionary for that purpose, and for I in suppose the string representation of the number n, I will take every I. If I say if I not in, if it is not present in the dictionary, I just need to have an entry for this item. So di equal to, I will write dictionary item of I. Suppose for this I will write di equal to 1, and if it is not the case, then I will just increment the count of di by 1. So this is what I am going to write, di equal to di plus 1. So in this way, I've just calculated the count of every digit that is occurring inside my number. So finally, I'm returning this dictionary D, which is having a count of every digit that is occurring inside the number, and the key for this dictionary is the digit. And now we'll come to this method, that is a solve method. And first of all, it is taking an argument 10. This is a string, so first of all I just need to convert it into an integer, because I'll be performing integer related operation. And let us before that let us find the length of this number. Okay, so length equal to len of the number n. And now I'm going to take three different cases. And so for these three different cases, I'm going to have different solutions. For example, if the length is 1, then what will I do? So if length is 1, that means it's a single digit number. I just need to check if the number modulus 8 is equal to 0. If the number modulus 8 is equal to 0, in this case, I'm going to return. Okay, so if the number is divisible by 8, then I'm going to return yes. Else, I'm going to return a no. So for this case is quite simple. Now let us see a little complicated case. If the length is equal to 2, if the length is 2, then what will I do? So if the number is divisible by 8, or if the reverse of the number is divisible by 8, so I need to apply both these conditions. Or the case is that reverse of the number. So I'll just convert the number to a string, and then I will find the reverse of the number, and then again I will convert it into an integer representation. So this is an integer representation. I will check that if it is divisible by 8. If this is the case, if any of these two conditions is satisfied, then again in this case I'm going to return a yes. Okay, and if this condition is not satisfied, then I'm going to return a no. So this is quite simple. And now I have checked for length 1, length 2, and now I need to check for length that is greater than 2. So it can be anything, greater than 2, anything. So let me first of all generate an array for I in suppose this is an array which is containing all the numbers which are divisible by 3-digit numbers which are divisible by 8. So I will write for I in range, and then I'll give a if condition. If I modulus write like this: if I modulus 8 is equal to 0. If this is the case, then I'm having this array. So this is my array, and then I will calculate the frequency of the digit. Okay, so calculate the frequency of the number n. So I'm having the frequency of every digit that is inside my number. That's why I have given the argument, and I've given this argument n. And now I need to run this loop for every of this of every this three digit number which is divisible by 8. So I will say for val in suppose ARR. Okay, so for every value that is occurring in this number, I will have to first of all do this, calculate the frequency of the value. Okay, so this is quite simple. So see, we are having two different dictionaries. One is this my D dictionary, and one is my P dictionary. So this D dictionary is for the number that is containing a count of every digit that is occurring in the number, and then I am having this P dictionary which is having a count of every digit that is having, and that is of the three digit number which is divisible by 8. So I just need to check if if the count of every digit that is occurring in P also occurs in D. Okay, it is also in D. So how will I do it for every digit that is in P? So I need to run a loop in the I need to say something like this: for item in P dot keys. So every digit that is occurring in P, it should also be there in the dictionary D. So first of all, if I will check, so I'll do one thing. If any of the condition is not satisfied, I'll just make bool equal to, initially I will say it is true. A boolean variable. I have this is a boolean variable. Initially, I'm just setting it to true, and then if I find that this key is not in the dictionary D, then I will just make this boolean value to be false, and I will I will break away from here. So just let me check it over here. If I say item not in D dot keys, okay. If item not in D dot keys, if this is the case, if item is not in D dot keys, then I will say bool equal to false. Okay, it is equal to false. So bool equal to false, and I don't think I just need to continue away. I don't need to continue from this point, so I will just say break. Okay, and then again, if this condition is not if this is not the case, then let me have another if condition. If for example I will say D item, if the frequency of this if the frequency of of the number which is occurring in the dictionary, it is less than what occurs in my P dictionary. Okay, so I am going to write item. If this is the case, again, if this condition is satisfied, then I will write bool equal to false, and then I am going to break. Okay, I'm going to break away from this point, and then once I am through with this I'm through with this loop, then I will check if if the boolean value is still false. If it is still true, then I will return yes. Okay, in this case I will return a yes, and once I run through this on this for every value that is inside this array, if none of the three digit number is occurring in the number which is given to me, so I will just print a false. So if this happens, then we have not encountered this return. That means I'm just going to, once I come out of this loop, I can just simply return a no. So once I come out of this loop, I'm just going to simply return a no. Return no. Okay, so this way I have done this. So for every, we have done it for every case. If the length is 1, if the length is 2, and finally for all the length which is greater than 2. So I have taken two dictionaries. One is the D dictionary, that is for the number, and then one again there is a P dictionary which is for every three digit number which is divisible by 8. So let us try and run this solution, and before running this solution, let me call this. Suppose I say solve, and I just need to print it also. So I'll print it also solve, and I will give a string. I will say I will say 128. Let us test it for some simple number. Let us say 128. It should print a yes. So I'm going to run this F10. See, it is printing a yes. Okay, so I think it is running fine for small digits. Let us try some other option. 129. This is not divisible by 8. Let me run it. F10. See, again it is printing yes. I think there is some mm, Okay, now let us see this problem for this number 128. So 128 is divisible by 8. So let us try and run this. Let us try and run this for 128. Let us see what happens. See, it is printing a yes. Again, if I suppose I have a number 104. 104 is divisible by 8. Let us again try and run this 104. It is printing yes. Suppose I have 105. It is not divisible by 8. And any permutation of this number 105 is also not divisible by 8. So let us try and run this. No, I can see it is printing. So we have applied this solution. Let us finally run this in my. Let us copy this and let us see if the solution is really working on HackerRank. Okay, so and so I just copied all this code. I'm going to this HackerRank ID and copying all the code as it is. Okay, so I have this cal frequency method, I have this solve method, and let us see if it works or not. I'm going to run this code. See, it's doing fine. Basic test cases are running fine. I'm going to submit this code. Okay, all the test cases are passed. So this is the solution. And so this is the summary of the solution. You are taking a number, you are taking a count of all the digits which are occurring in the number, and you are taking and finally you are taking also an array which is containing all the three digits number which are divisible by 8, and then again you are running a loop for all the number which is occurring in this array, and I am also taking account of all the digits which are occurring in these three numbers. And if suppose if the dictionary for the number is D and it is and every item in, and suppose the dictionary for each entry in this array is P. So if every dictionary entry in P is in D, it must be in D, and also the count of every dictionary item P must be less than or equal to in dictionary D. So if these two conditions are satisfied, then any permutation of the number can have these three digits which are occurring in this array as one of its permutation. So that number will become divisible by it. So in this way, I'll solve this problem. It's a good problem, and it's of 50 points on HackerRank. So this is the solution. I'll be given the solution in the link below, so you can get this solution and you can apply it also. Okay. And before just copying and pasting the solution, I would suggest that you try and run this code on your own self. Okay. So I'll just end this video over here. See you in the next video.